Hello, everyone. My name is Andrew Deswani. I am research associate at the University of Luxembourg. Our research is about privacy preserving for genomic data, which is called PP for genomic. We know that clouds do not guarantee that genomic raw data that they host can be either accessed by the cloud service provider or be vulnerable to privacy attacks by an exterior adversary. And consequently, the increased availability of next generation sequencing technology has come with a price, namely an increased vulnerability of personal biodata to privacy breach. Indeed, an individual's genomic is privacy sensitive because it's uniquely associated to its identity. And in addition, genetic variations are also correlated with private health information, such as disease predispositions. Several privacy attacks have been reported in the scientific literature, which pushed the research community to develop privacy-preserving solutions for secure genomic data analysis. And in this regard, few solutions have been proposed so far. For instance, data de-identification, which personal identifiers such as name, age, or zip codes are removed. Data augmentation has also been proposed, in which every data sample of a given individual is generalized so as to make it distinguishable from other data samples from different individuals. Or cryptographic-based methods have been put forward to encrypt genomic sequences and make them less vulnerable to adversarial attacks. Each of these approaches has to face a trade-off between privacy and loss of utility, and none of these methods focuses on attempting to protecting the raw reads at the beginning of the sequencing pipeline, right at the beginning of the sequencing machine starts working. So in this aspect, these assets propose an early read filtering solutions termed genome mask. The requirement for an effective early read filtering technology are multifold. First, we try to detect a maximum of nucleotide deemed sensitive, and then we use to filter throughput, which should be comparable to next generation sequencing throughput. And at the end, we try to keep our filter relying on limited hardware resources. So our demos includes two entities, which includes a client and server. In client, the client should be represented by any machine that pilots and controls a genomic sequencing machines. Let's just start our demonstration, which in the client side, it receives a raw data files from the next generation sequencing and converts it to the raw file into a raw genomic reads, let's say FASTQ files. And then these FASTQ files are then, let's say, transferred to GenomeX box or server. And on the server side, which server side represents the GenomeX box, which receives the FASTQ files via TCP connection from the next generation sequencing machine, and it processes each FASTQ sequentially and outputs the performance in terms of throughput, which means that it processes a FASTQ at how many nucleus have been filtered, and it then creates a private file and public files where this first contains the filtered nucleotides deemed sensitive, and the later contains the non-sensitive nucleotides. So please do not hesitate to contact me in order that if you have any question. And thank you for watching this demo.